Hello. Okay. So, fancy shoes. Starting off, can everybody please just stand up? That's the noise I was looking for. Perfect. Hands up. Hands forward. And now sit back down. So hopefully some circulation so you'll survive for 35-ish minutes. Today I will talk about a bunch of stuff. So I'm happy to see a lot of people here, a lot of people that I know, have met before, and also a lot of new faces. I'll talk about learning and experience. Andre? So we will have a quick overview of what chaos engineering and learning from incidents is. There will be some jokes, because that's important for me. I will try to draw some parallels from my journey as a martial artist. And then we will have to do the most important part of this year, talk about the Gen AI. It's not a Gen AI talk, but we need to address it for valid use cases. So today we will use it in one way to improve the resiliency of our systems. This is the slide I hate the most, but I have to have it. This is who I am. My name is Marcus. I work as a DevOps engineer and an evangelist at Node Cloud here in Malmö. I am also part of the AWS user group here in Skåne, together with Susanna, who's in here, as well as Jimmy Dahlqvist. So if you're interested in AWS, you probably know about us in Malmö. I'm also part of the AWS Community Builder program, which is similar to the Azure MVP program, just people who make a lot of noise and try to share some knowledge regarding AWS as a platform. On a less professional level, I am a black belt in Brazilian jiu-jitsu, and it kind of defines me, which is why I got to have these lovely slides. I also very much enjoy making Napolitan-style pizza. So I have an oven at home, and I make shitload of pizzas. Sorry for cursing. If you're curious about dough or tomato sauce, we can chat afterwards. There we go. So a long, long time ago, in a galaxy where you all live, I started doing jiu-jitsu. As most everyone, once starting out, I was awful. And the Dunning-Kruger, but I was like, I really, really enjoyed being awful because I was under the assumption that I wasn't. So the Dunning-Kruger effect was in effect a lot. I'm a male, I watch a lot of TV, I watch a lot of sports. I can definitely beat people up. Well, that's not true. So for people who are not aware, Dunning-Kruger effect is pretty much just people who have no idea what they're talking about think they're really good at something. Example, men who think they can beat bears with their bare hands. Not a single laugh, damn it. That was my best joke. Yes. It quickly became evident that I was awful, but in an environment where we all strive to learn, as long as you try to learn, as time progresses, so do I. And every now and then, there was these periods of things just clicking, you know, when you're just, nothing works and then shit, everything works. And this is the same in IT, right? You're looking at code days on end, nothing works, and then I can fix this and 100 new things. Everybody has been in this circle where we go back and forth, nothing works, everything works. I am a god, I am not. And not just the clicking part, but I also had a bunch of plateaus, which is we experience that we're not learning, but it's not necessarily true. This is super common when we're learning in groups. So we are still progressing, but we can't really tell because the people we are progressing with are progressing at the same pace. Simple example, when you're overtaking somebody on the highway, and suddenly they decide, I'm not going to be overtaken. So you go boom, and then suddenly you just keep going side by side for forever. This does not mean that you're not going where you're going. It just means that your perception isn't true. You're still getting where you're going, but other people are perhaps picking up. So, what is chaos engineering? I obviously have one answer here. How many has heard about chaos engineering before? Fuck. Then I can't lie. That's nice. So I'm going to talk a little bit about Amazon Q today. So that is their chatbot kind of thing. So I had to ask it, what would you call, or how would you define chaos engineering? And this is a lovely, hey, Lovely, lovely answer I got. Chaos engineering is a disciplined approach to improving the reliability and resilience of complex distributed systems. That's a lot of hoo-ha. But it's also very, very true. I try to generally define it as a way for us to test our systems to learn about them. So it's not necessarily figuring out what is right or wrong. It's about getting an objective view of what we have. So Netflix made it super popular around 2017 because at the reInvent keynote. So reInvent is a large AWS conference in the US, a lot of people. And Nora Jones, who was working at Netflix at the time, got up on stage in front of like 20,000 people and explained how Netflix is doing this. So this is how the greater populace learned about Chaos Monkey. And Chaos Monkey is just a cool name of a tool, and previously was part of a larger group called Simian Army. But what the Chaos Monkey tool does is it terminates resources. So it just shuts them off. So initially it was just virtual machines or containers. And the safe way is that you tag resources, so you don't just go everything dies. But when you get mature enough, everything should die because you have stuff in place to make sure it's resilient. We get back up. So when you are browsing Netflix, this is super evident because whenever you log in, you can tell that you don't always have My Picks or Continue Watching at top. Because currently when you logged in, those services were dead or not reachable. So you'll just get them further down when you're scrolling through. So this is a very simple way to tell, because they have a nice series of degradation. Instead of not saying, Netflix doesn't work because this category is down, just take everything else because we know you like this too. So the catchphrase we used to use for chaos engineering for the longest time was break stuff on purpose, because it sounds really cool and that's marketing. But when you look closer at the actual practice, there is a lot of emphasis on making sure that you only break things that can break and the things that you know should work. So if you know that this is broken, we don't try to break it more. There is no value in this. The process of validation here is very close to what the scientific method is. It has a process where we have to define the steady state, hypothesize, introduce failure, and disprove. So this just means that defining a steady state is what does our system look like when we are normally operational. Normal load, everything. And we as an organization have to define those metrics, whether it's sales per minute, streams per second, CPU load, what doesn't matter. We need to define how our system looks so that when we test it, we can verify that it still looks the same or behaves the way we think it should. So the most normal case is, I know that when my system gets more load, we scale or we throttle. We make sure that we don't kill everything. And we obviously have a boatload of monitoring in place. So that is, we understand that when we get the load, we get the metrics, and then we act accordingly. The key part here is when we test things, we need to learn from this because things will break. And when stuff breaks, what we do is we discuss and analyze and try to figure out how to go from here. So just to be very clear, we don't have to fix everything because certain cases may happen and it's super expensive to fix. But this is a design, so it is a trade-off that we have to make as an organization. Certain failures we can accept. If you are Amazon, you do not enjoy being unable to check out products for 10 minutes because you're losing millions. If you are Bob's tapestry stop in Höllviken, it's probably fine if it's down for 10 minutes. And it's not necessarily fine to pay for all the extra servers and resources. But whenever something happens and we test it, we now have more information regarding our system. And this is not I think, this is I know. And that is the most important part. So a common thing people always bring up when I talk about chaos engineering is, but we're not Netflix. And you don't have to be. So when they mention that they're not Netflix, what they usually mean is one out of two things. Either that they have a very small system, so there is no reason to spend a lot of time on this. Or they do not have dedicated people to do this. And I'm super friendly, so I'll offer you these thoughts. Any system will eventually break. There is not a system designed ever that will never fail in any way. So if you do your best when designing the system to actually try to remediate things that you know might fail, for example, take scaling into account, how do we throttle requests to APIs, to databases, all these things, then you've already come a long way to building a resilient system, but you don't know anything, you just think. And if you build anything today, you should have a quality mindset. So when you're building a product, there should be testing involved. If you're pushing code that is not tested, I'm quite sure stakeholders will not be happy eventually because there's stuff going into production that will cost you money. Same goes for the resources that we run our systems on. Sorry. And if we take some time in every sprint or session or period, whatever fraction you compound work in, and set aside time for quality work, whether it's testing or resilience testing, that will save you money down the line because then you know what a failure might look like, and then you can take that into account before it happens. Because nobody is as efficient as an engineer waking up at 5 a.m. on a Saturday morning trying to figure out why everything is broken, right? The next big is that we don't, so a big concern is usually we don't feel comfortable breaking production. Well, you're going to anyway. But you shouldn't start in production. So if you're trying to do any form of chaos engineering, you need to have monitoring in place primarily so you understand what your system looks like. And there are some mechanisms in place for you to get alerts when stuff doesn't work as it should. But when you have that in place, you don't have to tear down production. Usually we have some form of non-production, dev, test, whatever you want to label it. That's where we can do the basic test first to validate, okay, I think this will happen. And if we crash dev, nobody cares. So we'll start there. And when we validate that it works in test, then we progress up the chain. And if we're not comfortable doing it in production yet, don't worry, you can stay here. You still have information that you can now base future design decisions on. Because you realize that your system is designed for this type of efforts. And this is the type of engagement we get from customers. So take that always into account. And like simple solutions, so not always hammers. Simple solutions can be introducing latency in workflows or dropping connections. So you don't need to terminate the database. You can just say, okay, for every call to the database, drop 20% or introduce 100 millisecond latency. See what happens. Because when we have distributed complex systems, you're going to have cascading failures. This breaks, so this breaks, so this breaks, and then everybody wakes up. So like start small and move forward. So there's a really good book written by Casey Rosenthal and Nora Jones, who I mentioned earlier. That's called Chaos Engineering. If you would like to read more about the history and more some practicality examples from Netflix. It's really good, and I recommend buying it, but it's expensive. So the end goal of any chaos engineering experiment, so they're not called tests because tests can fail. Experiment is a matter of learning and figuring out what happened. It's just knowledge. We want to learn more and be certain of what we actually know. So I'm harping on this a lot because a lot of us who've been doing this for a while, we know so much about our system, but a lot is not validated. It's just our opinion. What if I'm going on vacation next month. I'll be gone for a month. Anything I know about our systems will be obsolete because my team will keep working. They will change stuff, improve stuff. So I need to keep up to date because my knowledge, which is super certain today, is not in the future. So we need to keep validating. In this case, there is another great field that goes hand in hand with chaos engineering. It's called learning. This is learning from incidents, and it comes from the field human factors and system safety. It's a mouthful. In short, this comes from the industrial industry where we manufacture things. A lot of people don't enjoy getting their hands cut off while building stuff. So there's a lot of processes in place for figuring out how far from the saw can my finger be before I need to turn it off. So before it was around here, not very cost effective. So now it stops like less than a millimeter from your finger because there's a lot of processes, because we understand that even if we are doing our best, sometimes mistakes happen. So we need to have processes in place for this. And this is exactly the same in IT. So when stuff breaks, we try to figure out what happened. So normally you have like some form of post-mortem root cause analysis where we sit down and say, okay, whose fault is it? And I'm sure it's Louis' fault. I can point at him because he's in my team. And yet generally what we get to is human error. Super simple. I pushed code, my fault. But if we stop there, we rob ourselves of the opportunity to learn. And it's not uncommon that the failure is actually a fact to me. Like an individual can make mistakes. It's not about saying that we are not responsible for the actions we take or how we act on our systems. But just like Shrek, we have layers. Yes. So if we don't peel back the layers, we don't get to the core, and there is not room for us to actually learn and grow. So we need to focus on improving ourselves, but also the organization, because usually I do my best. So if I mess up, it's usually the organization's fault somehow. Not because the organization is malicious. It's just a relic of before, or this is how we used to do things, or we thought this was fine. But if we trust that the people we hire and work with, that they are qualified and always doing their best, then we must also trust that when one of us breaks something, it is the organizational fault. Perhaps there weren't enough checks and balances in place, or the review process wasn't rigid enough. Maybe we overwork our staff so that they get tired and miss things they wouldn't otherwise. So if we can talk about why the human error occurred, then we might actually find something valuable. So this will be my first key takeaway when it comes to various levels of experience and learning. When you are inexperienced, it is easy to fixate on one thing, especially when it seems correct. And to be fair, if a person did something, they did. But to avoid getting trapped here, one method that you can use is the 5 whys. Super fancy agile stuff. But it's super simple. It is just keep asking why until we actually get past I click the button and we get to why I clicked the button. So one example that I did at my client a while back, I made a quick update to some IAC code, so Terraform, resources as code stuff. I pushed everything to main, and the system became unresponsive. So why? Duh, I push stuff breaks. But if we just figure out, okay, I pushed, fire me, I will never push code again. But this does not prevent anybody else from doing the same thing. So why did the system actually break? Because I updated runtime of certain dependencies and applications. But why would the runtime update actually break the system? Well, because apparently when you update certain runtimes, other dependencies, other things that rely on those don't enjoy breaking changes. But why did I do that? How could I actually just update it and break everything? Well, I've been at the client for quite some time. I was hired as a senior lead. This is a cool title. This also comes with the secret permissions to do everything because I know my stuff. You're laughing, but you know it's true. You have everybody who's working in an IT team know there's this person that you'll just go, please fix it. I don't give a shit. Please just fix it. And they will. But sometimes stuff breaks because they can circumvent the process. So why could I do that? Well, it was super easy to give me full admin. So I didn't have to go to Louis. Please, can you look at this check? I checked. I bumped one version. Can you please review this? Oh, also get another one because we have 2 reviewers. Nah, just do it. It'll be fine. We trust you. That's not ideal. So why? The organization trusted that I would make smart decisions and not, in this case, be tired and stressed and mess up. So in this case, I can stop at 4 whys because we got to the problem. I got admin when I shouldn't have. I was allowed to circumvent the process. But suddenly we see a problem in the organization. some people are allowed to be outside of the box. And when you allow that, you get creative people doing amazing things, but you also get stupid, smart people fucking up shit. So that's a trade-off, and I recommend not doing that. If you're a startup, if you don't have customers, go as hard and fast as you can, just break everything. But when people are relying on you, there needs to be checks and balances. And there should always be some form of review process. If everything's on fire, I'm not going to be alone solving it. So when I fix something, I'll talk to somebody in my team, like, can you just double check this fact? They should be right next to you, either physically or online. Somehow you should be able to collaborate. So, okay, this looks good, go. Because sometimes a comma can be the difference between a lot of money in cloud spend. So recursive lambdas, for example. I think that's solved now. But inexperience is just a state. So over time, you transition out of the state due to having, well, you guessed it, experience. But it is not uncommon to correlate age with and or tenure with knowledge. So when people meet me the first time and don't know me, they know, okay, I have a little gray in my beard, I'm old-ish. I'm almost 37, so it's not old, but it looks, adult. That means I should have been doing this for a long time, so you should listen to me. But there is no correlation with my age, because you don't know how long I've been doing this. If I started doing this just out of school, I would have 15 years of experience, which still doesn't necessarily mean anything. But I only have half of that, because I did other stuff before that I was even worse at. Yes. So should my lack of potential experience lessen my value? And this is the best answer everybody gives all the time. Depends. Because it depends on what I've done in those 7 years, right? So if I put a lot of effort into learning from all of my experiences, talking to people around me, taking accountability for my mistakes, and making sure to ask a lot of questions, then those 7 years are a lot of value, a lot of experience, a lot of knowledge. If I'm Bob, I always blame Bob, sitting in a basement doing Pascal for the past 40 years, there is no incentive for him to learn. He's just happy chilling. So he's never learning. Is that 40 years of valuable experience? I would say it's not. I would say there's a lot of domain knowledge, but there's also a lot of issues with not actively trying to learn. Because we also have the people who just show up and do the bare minimum, right? And to be clear, the bare minimum is what your employer is paying you to do. That is fine. Because if it wasn't fine, you would be fired. There is a line somewhere. You don't have to be the high performer who does 70-hour weeks. So you can ask my team. I work 40 hours on the dot because I prioritize other stuff as well. But during those 40 hours, I believe you should do your best to deliver the best quality you can. What that means is different for everybody. But you should go to sleep knowing that I did my best. I might still be the worst on the team, but I'm doing my best and I'm trying to improve over time. And you should not work yourself to death because you will be replaced on the day you die. Harsh, but true. So the way forward should always be to improve yourself, because in that way you will also improve the people around you. Yes. The most important slide, the one I was recommended not to have because people don't care about weird sports stuffs. I will go on a very quick jiu-jitsu trip with you to make sure everybody follows along-ish. Jiu-jitsu is a martial art where we hug each other, try to strangle each other, and we denote experience and knowledge by different color belts. So you go from white to blue, purple, brown, and black. If you're super old, you also go to red, but that's like 70 years of experience, so there's very few people. So these belts signify knowledge and experience. Yes, there are outliers who are high belts and crap, but there are very few black belts who have not put in the time to master the basics of the sports, whether it's jiu-jitsu, taekwondo, karate, or whatever other sports that follows the same type of system. So going from a white belt, this means somebody who just got in on the first day, knows nothing about the sport, to a blue belt, which is the first step. That is a vast change in knowledge and experience for that person. You go from knowing nothing to being able to fold a human person in half against their will, pretty much. But in the greater scope of things, they're still quite terrible, which is fine, because it's their journey. But you need to understand that when you accumulate just a little bit to set yourself apart from the mainstream, then you're already making a ton of progress. So if we're talking IT, straight out of school, you don't know crap. After just a few weeks at your new job, you probably have learned how to build a super simple API or style a button, which they do in front-end stuff, I've been told. Like, just being able to do those simple things, you now know stuff that my mom has no idea what it means. So we are still doing progress. And every step up until the black belt should reflect both learning and improving. And when you reach black belt level, the learning doesn't stop. It just signifies that you're capable of being let alone for some period of time without breaking everything. The pursuit of knowledge should always persist. So curiosity is a valuable trait. It's supposed to be blank. I was trying to do a fully blank slide, but they were upset, so I got one. So that's enough jiu-jitsu talk. So let's hop back to computers and stuff. The very same thing applies to IT. When you're just, I've already been here, damn it. This is why you should memorize stuff, because then you get lost in slides. So now it comes the time to actually push the learning mindset. You have to be open to the fact that you are not always right, and there can be other ways to do things. This is where we cut our path. When we review someone's code, instead of just saying, this is wrong, fix it, invite to a discussion. Their solution might actually work, and by discussing, you can both learn. Even if you're super experienced and they're fairly new, try to figure out the reasoning. Either you learn or they learn. This is super important. And yes, sometimes people do really, really stupid stuff, and then you obviously have to correct them. But in general, when it comes to software development, it is not a matter of right or wrong. It is a matter of preference and trade-offs. So I've always used this type of algorithm for this type of issue. Or we should use plain JavaScript because instead of TypeScript because typing is for dumb. Like, this is not truth. This is opinion. So we discuss, and hopefully we both learn something, or all of us if we're a larger group. It's a matter of being open to different points of view. But what about speed and efficiency? If you like shitty action movies, you've heard this a lot because this is one of the mottos of SEAL teams in the US. Slow is smooth, smooth is fast. So taking each and every opportunity to be curious will compound over time in terms of knowledge and experience. Not only that, work will be more fun. And that is like really cool to do something you enjoy and also have fun while getting paid. Not everybody has that luxury, so you should make sure that's where you're at. And when you do these types of exchanges, this is a culture building activity. And it doesn't have to be in the same room. It doesn't have to be synchronous. We can do it from different ends of the world as long as we have a proper way of communicating and an open mind. Because if I'm super junior and the senior on my team feels comfortable saying, oh, I see this cool thing you did. I don't fully understand. Can you show me this? Because there's people today learning stuff I don't even know exists that's super cool that I could learn, even though I've done this for way longer than them. So like, taking this as an opportunity is super useful. So let's talk about chaos engineering. And I will use AWS's own solution for my examples. It's called Fault Injection Simulator. It has the most hilarious abbreviation known to man, because it's fart in Swedish. But the concept applies to any tool you may use. So don't feel like this is an AWS talk. Concepts, it's just one tool. There are plenty of tools to run. Azure has their own, for example. There are open source libraries you can use. This is probably the coolest diagram you've seen all day. You're welcome. I haven't architected for a long time, so this is where you end up. But to set the stage, this is a very, very simple application that is hosted on an EC2 instance, just a virtual machine in AWS, and it has some data in a database. And this database is a hosted service, not super relevant, but you don't have to worry about more so than paying for it, pretty much. So if we would like to conduct a chaos engineering experiment, I need to know a few things. I need to define my steady state, as I mentioned previously. This means that I have some metrics for performance of the system when under normal load. These metrics vary from system to system, of course, but to make it simple, in this case, we track CPU load, memory usage, and dropped connections to the database. So now I need to formulate my hypothesis. I believe that when my system is put under heavy load, so in your case, you need to define what heavy load is. Like my personal page has 7 page views a month. So if I get 10 page views, that's heavy load. That's almost a 50% increase. But if you're Amazon, like 100 million requests in a minute, but the system will throttle requests. So when I get this heavy load, my system will throttle these requests. Make sure that the end user gets the exact same functionality, but at a slightly degraded pace. So Ticketmaster, when you want to buy Oasis tickets, you go into a very nice line that says, you are now 1200 in queue. Please wait. This is one solution to throttle. It's not necessarily a good one, but it is one. So this is what I think the system will look like when I put it under load. And then we did attempt to disprove this hypothesis by introducing our failure. In this case, that would consist of a few types of load tests. We can focus on either stressing just one of these metrics, the CPU, memory, or the connections, or we do the full blast, where we do everything at the same time. So that decision needs to be based on confidence and maturity of the system and organization. And when we're talking organization, primarily it's the people working in the organization. So if something breaks that we think shouldn't break, we need to have the people around to help fix it. If you don't know yet, then you shouldn't go in production. It should be a very tiny one, and you should just maybe do 5 minutes of CPU stress. See what happens, because it's usually the simplest place to start. The key part here is for any chaos engineering experiment is the abort button. Otherwise, you're just yanking cables. Whenever we do an experiment, we need to define a threshold of when the system is not performing as we want. And then as soon as we pass that, everything just stops. So all the load just goes away. And we hope that the system just falls back to where it should be. So this is why monitoring is important. We like to keep track of our system so we know whether it's doing well. Especially when we think that turning the load off should be fine. But if you're doing it in production, there are still risks for cascading failures, even if you've been very, very diligent about narrowing the blast radius. So make sure until you're super comfortable, have people on hand. When the experiment is over, no matter if we crash the system and had to abort, or if it passed with flying colors, we now know more. We have either learned that we have thought what we thought we knew was not true, or we have verified that our knowledge is true. I'm going way slower than I used to, I'm sorry. So this new knowledge should inform future decisions and discussions. When we conduct experiments, it is important that we only test things that we believe should work, like I mentioned previously. If we know that our boat has a hole in it, you don't need to put it in the water to figure out that it's going to sink. So fix the hole and then we launch the boat. There is very limited value in figuring out that the boat sinks, right? But what if you don't know anything about chaos engineering? Other than it sounds really, really cool. You can use Amazon Q Developer. So it's like GitHub Copilot, ChatGPT, whatever. It can help you improve, like fix minor code stuffs or talk about architecture. In my use case, I will talk about, because I don't know anything, so I'll ask it about my system. I will show some pictures here. They're mostly to prove to you that I actually talked to the bot. Thank you, that was nice. And yes, I do use a pink theme for VS Code. It's awesome. You don't need to read the pictures that I'll show next. They are just there for flavor. So I will try to show 2 different cases where I'll show a white belt asking questions, so a beginner, and a black belt, somebody who is more experienced. So just to be clear, black belts are not these grandmaster arch wizards. They are just more experienced. And a disclaimer, any and all information provided by anything or anyone should always be verified, especially Gen AI tools. Be curious and be positive. So, you can't even see, you can see it's a little bit pink. So for the first scenario, I'm asking a very normal question from a beginner. I have a server that is slowing down due to high load. How can I use FIS to test the resiliency of my system? So the last part is not super normal, but my server isn't working is super common. So we get a response with some marketing stuff about how great FIS is, but then we actually get good suggestions based on the very limited information we have provided. So it describes chaos engineering process, provides an example of how to perform an experiment using the CLI. It also informs me how to act when the experiment is done, as well as letting me know that we need to limit the blast radius. So run the experiments in a controlled environment with proper monitoring and safeguards. So this just go over what it will do and how long it will run. And then we have the really good stuff, suggestions of what to do when the experiment is done. So obviously, a Gen AI tool will never lie. So I trust this information and just run the experiment. Lo and behold, the server crashes. I'm not particularly happy about this, so I return to queue and ask, my EC2 crashed when we stressed the CPU. How can I solve this? This is where the value becomes more apparent. We get told that it is valuable to learn this, so we shouldn't just be upset. We should actually take some solace in, we fucked shit up, we can move forward. I really need to learn to not swear, I'm sorry. So we get suggestions on how to troubleshoot. And not only that, we are getting remediation suggestions. Some suggestions provided on how to remediate it. We could optimize our instance types. So there are different types of virtual machines that you can use. So if you have a CPU-heavy application, you can use an instance that is more optimized for CPU load. Same for memory and network. So that is something you can take into account. It's usually a discussion for an architect, but it's good information to have that you can bring this to the team. Okay, so this broke. It says, look at this. What do you think? It can start a discussion where we can learn. Or they can implement auto-scaling, which just means that when our metrics hit a mark, we add more resources to share the load. And it also suggests like you could focus on optimizing the application. To do that, you would need to pass in all the logic and have that processed, or have people in the team who already knows we have bottlenecks. But the suggestion is there, and it's valuable. So, almost done. We are now at the black belt level. Similar concerns. We want to make sure that our system can handle heavy load. But since I have more knowledge, I am asking a more detailed question, and it pertains to the future of our system rather than the past or present. This time the question is, I have an EC2 as part of an auto-scaling group behind an application load balancer. I expect heavy load during certain periods. How can I ensure that my system performs well during these periods? These spikes. So this just means I expect a lot of load, and when you have it behind a load balancer and auto-scaling, when there's traffic, we just get more machines. So when we give a better question, we are also presented with more detailed response. In this case, that means we are presented with certain options that can help you expect spikes. Anything from proper alarm configuring to optimizing application or hardware. So just like the previous one. That is because it works. If you have a proper configuration for scaling, proper instances, proper monitoring, that helps a lot. But that's just architecture and system design. We're here for chaos. So let's see about, I want to specifically test what happens when we get a lot of traffic. Can we do that with FIS? And we can't, because FIS does not provide traffic. But it simulates conditions that mimic high load. So we get a few suggestions on individual tests. You can run CPU, memory, network, and some CPU, CLI commands. But the most interesting one is the final suggestion where they say we can run a combination experiment. Because when we get high load, a lot of things tend to pile up. So this then leads to the cascading failures we talked about, which is something we want to avoid when possible. Because we like it when one thing breaks and we only have to fix that thing. It sucks fixing that thing, finding out that 12 more things is broken. So this is a great experiment to run. It just stresses the CPU, memory, and throttle API calls to the database. I will have to run over for 1.5 minutes. If you need to leave, thank you. So in closing, I have a few things that I want to reiterate. It's an experiment. It is not a test. No matter the outcome of the experiment, you can learn. It's only not useful if you choose to not learn from it. Validating that your belief is correct is just as valuable as finding flaws that you can improve on. Only a SIF deals in absolutes, and there'll be one apparently. But try to avoid binary thinking. Don't be yes or no. Ask why, how. Do this to invite discussions and be open to more opinions. And then the great philosopher Ted Lasso. Be curious, not judgmental. Muito obrigado pela todos. So that means thank you in Portuguese.